Alright people, welcome back. So today we're dealing with problem number 13, Roman to integer. And apparently we basically have to convert the Roman symbol, like this is 1, 5, 10, 50, 100, 500 and 1000. So Roman numerals are represented by 7 different symbols. Yeah, for example 2 is written as 2. Just 2 ones are added together in 12. Yeah, okay, written as XII. Okay, fantastic. So I suppose what we have to do is to transform the Roman number into an integer number. Given a Roman numeral, converted to an integer. Okay, let's see what's written here. Roman numerals are usually written largest to smallest from left to right. However, the numeral for 4 is not I. Instead, the number 4 is written as IV. Because the 1 is before the 5, we subtract it by making 4. The same principle applies to the number 9, which is written as IX. There are 6 instances where subtraction is used. I can be placed before V and X. X can be placed before L and C to make 40 and 90. Yeah. C can be placed before D and M to make 400 and 900. Okay. Even a numeral converted to an integer. Okay, this seems nice. This seems really nice. So we have a string. Okay, our string in a numeral, and of course we need to. Shall we create first a dictionary by mapping a symbol to a value? Maybe yes. Okay, so of course we can iterate through the string and then say if the first symbol is I, then map it to 1, and then if the second is this, then subtract 1. I think that considering the number of symbols, we could come up with a number of if-else such that in the end we cover all the possible cases. But yeah, I think this is not the most efficient way to approach it. So let me think a bit. Oh, let's look actually at the example. So for example, if the input is s equal to I, the output is 3. If the input is s equal to LV, I, the output is 50 plus 5 plus 3. Okay, so you see what I mean? Okay, so this would be a difficult one. Okay, so my idea is to simply, let's map each value to a number. And then once we have the numbers, we do some operations to see which numbers have to be added and which numbers have to be subtracted. So I go with something like that. Let's go outside of this class, or maybe inside, doesn't matter really. But so let's define. I think we need a dictionary. Yeah, let's call it dict, and maybe better to call it dictionary entirely. So my idea is let's map I to. Let's map it to 1, of course. Yeah, of course. I is this, and then of course we want. Let's follow here. So V is gonna be 5. And so on and so forth. You see what I mean? X is going to be 10. L is going to be 50. And C is going to be 100. D is going to be 500. And M is going to be 1000. No clue how Romans were able to write like a million. This would be interesting. I don't remember exactly that, but it doesn't matter. Let's focus on the algorithm now. So of course I can do something like for letter in S, you simply take, basically we want to take from the value associated with the letter in dictionary. So we may want to write something like dictionary letter. This is basically the value. Okay, and for now, just, of course this is wrong, But let's say that we just add numbers. Of course, there are times where you have to subtract, but just to make it as simple as possible, let's write that the result is 0, and then we add everything, and then we return a result. Of course, this is gonna be wrong for some cases, but true for others. For example, here is correct because it's only summing. Here is incorrect. Why? Because of course here it's MCM. Okay, so this is gonna be, so this is 1000 plus 1000 minus 500. So this is like, only this is 1500. No, sorry. This C is 100. So this is gonna be 1900. And then you want to sum, this is 40. So this is 90. So it's 1994. Okay. So given all of that, how can we take that into account? So what I was thinking to do is to basically, we have to understand when a value must be summed and when a value shouldn't be summed. Okay, let me see. I can be placed before V and X to make a 4 or a 9. X can be placed before L and C to make 40 and 90. C can be placed before D and M. Can't we simply do an if-else statement for all these cases? So, for example, for letter in S, if letter is equal to I, then I simply say, maybe then it's better to do for letter, let's do for I letter in enumerate S. Yeah, so basically, if letter is equal to I, then I want to check if my S, I want to check basically if the next letter is equal to V or X. So if S of I plus 1 is equal to V, or S of I plus 1 is equal to X, then I want you to subtract the letter from the dictionary. Yeah, exactly. So I want the result to subtract dictionary letter. You see, I want the letter to be subtracted. And if I do that for all if statements, so for example, if I do that, if letter is equal to X, then if Si plus 1 is equal to L, or S of I plus 1 is equal to C, then I want the same thing. Okay, I want this. And then finally, same stuff again. So I can just copy that, put it there, and if the letter is C, then if it is Z or M, I want to subtract it. Otherwise, let's write elif, because of course this is gonna be then an else statement. So else, I add the result. That's basically what's going to be. No, because it can be I and it can be not this case. So I can just copy this else statement and I can put it there. Yes. Maybe not the more elegant way, but still it should work. Let's see if it works now. Runtime error, yes, because I didn't write it correctly. What's wrong here? Of course, string out of range. Yeah, of course. Of course, because I want if I is equal to length of S, then of course let's calculate, let's call n the length of S, And then if I is equal to n minus 1, then I want just result to be added to the dictionary, wherever it is. Boom. String index out of range. And then you return result. And then you break the for loop, maybe. Why is that wrong? Maybe this is because, of course, I have to, if it's not I, X, or C, I want, of course, the same stuff, result to be added to the dictionary. Like, sorry, the letter, we take it from the dictionary, and then we add it to result. I think that's the problem. We're never summing anything that is not I, C, or X. Yeah, exactly. So as you can see, this, well, first of all, what's the complexity of this? I think it's just on, because we just have an n for loop, but it's very ugly. Also, we are repeating stuff. We have a lot of if statements, so I think this can be improved a lot. Let's just submit it to see if it works, and it does. But let's improve it a bit, because now it's really, really ugly. So my idea is, instead of using this so many for loops specifying the different letters, can't we simply say if the number is less than the next one, then it has to be subtracted? Yeah, maybe yes. So I think at this point what we can do is this can be removed. Will I regret this? Maybe. And even this actually. Because then we can say, okay, so follow my idea. My idea is for I letter enumerate S, we just say if dictionary letter, okay, let's store it somewhere. Current val is equal to dictionary letter. If current val, and let's also store next val. No, because we have, of course, we have to check if I want to check if I is less than n minus 1. And so if this doesn't pass, then we don't go to the next one. And then if current val is less than dictionary, the dictionary si plus 1, then I want result to be I want dictionary si plus 1 to be subtracted by the result, from the result. Otherwise, I want the opposite. At this point, since it is called, no, sorry, not this. I want current val. And then I return. And it should work actually. And it doesn't. Okay, fantastic. What's the problem here? The output is -3. Oh, yeah, of course. This has to be plus, not minus. Okay, it does work. You see what I mean? So it's basically the same thing we were doing before, but without all the... Can we put this outside, by the way? Are we allowed to do that? So we are more clean. Yeah, let's try again. Yeah, guys, it works. This is fantastic then. So let's see if we have to do anything else. No. Oh, by the way, it is guaranteed that S is a valid Roman numeral in the range 3999. So we don't need to expect those numbers to be 1 million, I said at the beginning of the episode. Okay, guys, thank you very much. This was an easy problem today. It was pretty doable. So thank you very much for watching this video, and see you in the next episode.